Alright guys, today we're going to write and apply exponential functions. You need to stay with me today. The videos, if you can look at the top, it's only 5 slides. It's pretty short. This is the first one, so it's only 4 more. Really kind of stay with me, kind of go slide by slide, stop as much as you need to. This is one we'll have to really kind of, work things out in class tomorrow too, because you may not get it completely on the video, and that's okay. So get the best you can. All right. First type of problem is going to say, write the exponential function y equals a b to the x power whose graph passes through 1, 12, and 3, 108. Now, we've talked about this before. The reason the graph passes through 1, 12, and 3, 108 is because they work in the equation. So here's my equation right here. They're telling you exactly what it is, y equals a b to the x power. Now, one good piece of info is they gave me a point with a 1 in it, which is awesome. My x is 1 and my y is 12. Let me show you why that is so great. If I plug that in, and I know it works because the graph passes through it. If I plug that in, I get a, b to the first part equals 12. And also, I'm going to go ahead and plug in the other one also. I'm going to go 108 equals a, b cubed. Now, what I know is, because of this one is 1, I know that a equals 12 over b. That's exactly what a is. Really b to the first power, but that's just b. So what I'm going to do with this is I'm going to plug it into my a and my second equation. So it's going to look like this. 108 equals 12 over b times b cubed. All right, now, if I multiply that out, my b's would cancel. My b's and my b cubed make that 12b squared. If I divide both sides by 12, it gives me 9. So b is going to be 3. Technically, be plus or minus 3. We're going to take the positive square root because b has to be greater than 0. So here's what I know. I know that b is 3. And if b is 3, I can plug that back up here where I started. And I know 12 equals a times b to the first power. It is b, or 3. So that means a is 4 when I plug that back in. So my final function is going to be y equals 4 times 3 to the x power. Now that's all, that's quite a bit of stuff as you first look at it. Well, basically what I did is I took both of these points, plugged them both in, this function for x and y, used the easier one, which is the first one, to figure out what a would equal. I'll plug that in a, solved it for b, put them both back in my equation. Not that huge of a deal. It looks pretty impressive, but not as bad as it looks. All right, transforming exponential data. I'm going to go real slow on this one, just kind of read through with me. A set of more than 2 points, x, y, fits an exponential pattern if, and only if, the set of transform points x natural log y fits a linear pattern. Okay, that's a mouthful. Basically what they're going to do is they're going to give me a whole list of ordered pairs in x, y form. I'm going to take the natural log of all the y's, and if that's the case, if I do that and I get a graph that's linear like this one right here, that means an exponential pattern or exponential model fits that set of data perfectly. So if I have this set of data, which is obviously it's just like an exponential curve, exponential graph, and I did the natural log of all the y values, and I kept the x values the way they were and graphed those, that's exactly what I would get. Now notice this graph over here, instead of having x in the y-axis, has an x in natural log y-axis, and that's why it has a perfectly straight line. And when it gives you a line, that means that the exponential model is good. It's a good fit. That's what I need you to know from the slide. All right, here we go. It says a store sells motor scooters. The table below shows a number y of scooters sold during the X year that the store has been open. So this first row are years that the store has been open, and the bottom row are all the scooters that they've sold. Now what you hope is that the longer the store is open, or at least if you own the store, you'd want this to happen, that the number of scooters goes up, not just linearly, but it goes up exponentially. It goes up really fast. So you're hoping that's an exponential. So look what part A says. Draw a scatter plot of the data pair x natural log y, and then determine is the exponential model a good fit. So I took my calculator, and I wish I could show it to you, but I took my calculator and I punched in these numbers from my L1, and then my L2, I punched in the natural log of those numbers. And what happens, I got this set of data down here, and I graphed it, and it was a perfectly straight line. I wish you could see it. It's really good. Matter of fact, I may show it to you in the next slide. But anyway, so what I did now is I got to find the equation of that line, which should give me my exponential. So what I did here is I went ahead and set up on the bottom point slope form for 2 of the points in here. So I did y minus, I took the first one because that's the easiest one. Found the slope, remember how to find the slope. I did y minus y, took these two, minus x over x, found it was 0.35. So I'm going to work that out real quick. I'm going to first of all distribute the 0.35. When I do that, I get 0.35x plus 0.35, and move that 2.48 over to the other side. I get 0.35x plus 2.13. That's the sign there. There's something that didn't look right. I missed a sign right here. There we go. Now it's 2.13. Now to get the y, I'm going to, whoops, I thought I could move all that up. There we go, one thing at a time. Okay, not helping very much. So I'm going to do, to get rid of the natural log, I'm going to do e to both sides. So I got e to this power right there. That's just how you do the natural log. You do e to that power equals y. And because I have addition in my exponent, I'm going to kind of use a rule we used a little bit earlier, and I'm going to break that up into 2 pieces. I'm going to say y equals e to the 0.35x times e to the 2.13. That's a 3. Okay, now I'm just going to punch that straight in my calculator. E to the 0.35 is really 1.42. I still have that x power up there, and if I punch in e to the 2.13, I get 8.41. Okay, so that's what my equation is going to be. Let me see if I can write over here. Y equals 8.41 times 1.42 to the x power. Okay, that's quite a bit of stuff. I'll be honest. That's pretty impressive. So let me go through one more time exactly what we did. They gave me the set of ordered pairs. They want to know if it's exponential or not. So what it is, I took the natural log of all the y's, got another one, graphed it in my calculator, the new one, the x and the natural log y. It was very close to a straight line. So I did point slope form. I found 2 points in here, found the slope, picked a point, plugged it in, and got my equation. Okay, not as, not terrible, but pretty rough. So let me show you something else we're going to do. This might make you feel a little better. Good news. You can also use your TI-84 to find an exponential model for the last problem. What you can do is you can punch in your original numbers into L1 and L2. We've done that before with scatter plots. Go to Stat, Calc, and then look for XPreg. And what I got when I got my XPreg, this is what my screen looked like. And it tells me y equals ab to the x power. And I know you don't remember this, but the last slide we got 8.45 for the a, and we got 1.42 for the b. And my answer on the last slide was exactly this, 8.45 times 1.42 to the x power, which is exactly what my calculator tells me. So probably do a little both tomorrow. Please feel secure that your calculator will do some of these hard calculations for you. And I promise to work on this, and it'll make a lot more sense when you come in tomorrow. Again, don't feel too bad right now if you don't get it completely. This is one of those lessons that's designed to get a good head start on the video, and then let's fix it tomorrow when you come into class, and we will. See you then.